Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're here with our friend John Alexander. We'll be talking to him soon, geeking out about ML.NET. But first, do we have any announcements?
I had to do an unusual phone call today.
What's that?
I had to call my dog groomer to reschedule the dog grooming appointment because the dog is on vacation.
The dog is on vacation.
She thought that was pretty funny, actually.
So with Stacy?
No. The wife and I were away in Oslo. We were at NDC. And so Grandma was taking care of Zach.
Oh.
And Grandma took off. They went off into the up the coast. And they didn't get back. So
dog was literally on vacation.
The dog's on vacation. I'm not on vacation.
Wow.
And he missed his grooming appointment. They thought it was very funny. They still charged me the $10 cancellation fee.
Well, your pets always go away during the dog days of summer, right?
I guess that's true, but it's only June.
What are the dog days of summer, actually?
I don't know. I think they're just making things up.
Probably. Well, anyway, let's roll the crazy music for Better Know a Framework.
Ah, man, what do you got?
The periodic table of DevOps tools.
What period is it at?
From Zebia Lab. So, it's the very first element is GitHub, GH.
Nice. That's a great idea.
And on the other side, AWS, number 2. Amazon Web Services. And then number 3 is Git, GT. I'm not going to go through them all, but you get the idea.
There's going to be 140 or so of them, yeah.
They're organized, organized by category. It's pretty funny.
Yeah, no, they've actually, well, of course, the hilarious one is HG is Mercurial, right? Like,
yeah.
Because that already is an element, but even funnier. So somebody spent a long time coming up with punny names to map all this stuff out.
Yep.
The real question is are the noble gases really that noble? But I guess, yeah, look, they're all the cloud service providers, right?
That's right.
AWS, Azure, Google Cloud, Rackspace, OpenStack, Heroku. Somebody's thought a long time.
This is pretty cool.
This.
Yeah.
The challenge you get into really now is the actinides and the lanthanides, because these are both supposed to be radioactive. I mean, I love Datadog. That's not radioactive. Come on, it doesn't decay into anything.
Oh, I thought you'd get a kick out of that. And apparently you did.
You have amused me. Yes. You may stay.
So who's talking to us today, Richard?
Grabbed a comment off of show 1497, which we did at Connect in New York. We talked to Joseph Sirosh about AI and the future. I thought he was brilliant, didn't you? Such a smart guy. And the comment comes here from Maurice Peters. He says, great show. I just wanted to comment on the statement of the future of AI relying on the cloud.
Mm-hmm.
Although I think this is true while building models offline is based on large amounts of historical data, this theory does not hold when looking at other fields like AI for reinforced learning, which focus on online learning.
Yeah.
Modern RI algorithms also rely on neural nets, but continuously train and update and use the models for decisions making while real-time data comes in. This is obviously relevant in spaces like robotics, but also spaces like IoT, where sensors are continuously gathering data. So, to his point, especially I think it's the work you've done on IoT, where you can't necessarily rely on the cloud. You're going to want the neural net infrastructure more locally available.
Right.
Although the good news these days is, your average video GPU, even in a phone, can do some pretty serious neural net processing.
Yeah, absolutely.
And Maurice goes on to say, this also leads to the reality that the amount of compute power needed is actually not that large. Exactly. Once the core models are done, updating models is not that bad. Agents using RI algorithms nowadays compared to the RI algorithms used by AlphaGo Zero, which is, of course, the crazy model that Google built to teach itself Go by itself. It also killed at chess. Can be trained on relatively cheap desktop hardware. I personally don't think that it will take long before these algorithms will be used in the enterprise and might even become dominant. Think of learning facts about business processes in real time and then responding in real time, as well as using a trained model right away in real time as well. And that's a lot of real time.
That's a lot of real time.
But yeah, I think back to the 2 years ago now, we first did that developer platform talk, you and I, the joint keynote. And the one thing I have to update on that, quarterly, are the fastest computers in the world, like the high-end GPUs. Like, it's crazy how quick all that's going. And, we make that comparison that the Cray XMP, the supercomputer of the 80s, has the same gigaflops as a 2011 iPad.
Yeah.
And here we are flying up the hockey stick of Moore's Law. The GPUs are just getting more and more torquey. Like, we can do an awful lot in these modeling solutions with the kind of GPUs we have in small handheld devices. So I'm not going to argue with you, Maurice. You and I are on the same page. It was interesting to have that conversation with Joseph back in the fall. Certainly, Microsoft's own messaging has changed a lot more to that edge compute. That, you're going to have enough horsepower in the end to do a lot of that stuff. But I still think the cloud plays a pretty big role in setting those core models up. I just wonder how much we're going to be doing core modeling anymore. That bit by bit, there are going to be default sets of neural nets that we can do an awful lot of this work in.
Right.
So, Maurice, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
Absolutely. And I just did another one a couple weeks ago. It's
nice.
Actually, as of this recording, it's going out tomorrow, the 19th. Yeah.
I appreciate that you keep developing new ones. It's very challenging. But I got to tell you, I realize now there's the first 3 or 4 tracks have actually trained my brain to drop into flow.
That's really cool.
It's like I hear the opening chords to Blue, and it's almost like click.
You're just there.
Well, then I realize I've been super diligent with using it. Like, I only use it for that kind of work. I never turn it on when I don't need to flow.
Yeah.
And it's a stimulus response thing now, dude. I've hacked myself.
That's so cool. I hear that from a lot of customers too. That it just sort of snaps in.
I'm really grateful. I had dinner with Mark Seaman while I was in NDC, and you missed a good show, my friend. And,
I know I did.
We were talking about this stuff again. Just understanding that you can do the meta on yourself, right? To say, what is it that triggers the right things in me to get to the right place? So as I am committed to, tens of thousands of words of writing for the history of .NET, flow's super important to me these days.
Yeah, I bet. Well, it's super important to me too, because I'm working on a software project that has me working about 8 hours a day. So
nice.
It's fun.
Do you feel good?
I'm using it.
Yeah.
In the real world.
It's got to be fun to be in the groove, like just writing,
it's
cranking
addicting.
out code.
It's totally addicting. Billy Hollis is right. All right. Well, anyway, you can also follow us on Twitter. We hope you do. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. Uncle Owen would approve.
That is such an opaque reference.
I know.
There are 3 people who get it, and they're all on the call.
Yes, they are.
We'll talk about that in a second. But first, let me introduce John Alexander. The last time you were on, John, your bio looked a lot differently, but one thing that hasn't changed is that you co-founded the largest technical blogging community in the world, geekswithblogs.net, before selling it several years ago, and built music chart applications for Billboard magazine used by American Top 40. John sat in Kirk's chair on the bridge. He's recorded cartoon pilots as part of a voice ensemble cast, is the co-creator of the Geek t-shirt found at most Microsoft conferences, and we're getting all the, the real important stuff out of the way. He was also Facebook friends with Patrick Swayze.
Yes.
Not many people can say that.
Nope, that's the thing.
Yeah. John has a passion for designing and building accessible experiences using machine learning coupled with voice, touch, and virtual mixed reality. His secret identity is a mild-mannered senior content developer on the Microsoft Apex team, which is docs.microsoft.com, focused on ML.NET, .NET Core, and Docker. Docker, not Dakar. That's a country. He also is a former Microsoft Regional Director and Microsoft MVP and loves to paint, draw, game, do voiceovers, and spend time with his spouse and 3 children on all sorts of adventures. Welcome back, John. It's been too long.
Hey, thanks for letting me back on the show after, I think it was like show 85 or something like that with Barry Gervin. Many years ago, talking about Agile.
Yeah.
So
this whole new thing that everybody was getting hip to. Agile.
Remember that? Yeah. When that was the hip new thing. Good Lord.
That's right. Now we're talking about the hip new thing of, machine learning and AI, and it's been a focus of many of your shows, I know.
Yeah.
And we're just growing and learn. It's all a new frontier, especially for most of us that have just done either line of business development or enterprise development, and so that's kind of where ML.net came from.
Well, before we get too far into it, I want you to tell the story of that explains the joke.
Oh, yeah. Great. Thanks, Carl. Appreciate that.
That's awesome.
Typecast forever, John.
That's right. Okay.
So let's just say sometimes you tell a joke that is timed so perfectly and is so funny that nobody ever lets you forget it.
Well, that's right. You get one shot at greatness, and that has been mine. So, guys, remind me. I don't remember which show this was. It was
pretty sure it was a Tech Ed Orlando.
Yeah.
Was it Tech Ed Orlando, like 2000 or something like that?
Something like that.
Yeah, way back in the day. Okay,
way back.
So one of the RDs was doing something actually with robotics, and
it was that time when there was all these robot battle shows. And
That's
things.
right. BattleBots.
Right. And so it was a BattleBot thing that was made with a huge battle axe on the front of this thing.
It had a rotating saw, didn't it? It was something fierce.
Yeah, it was something. It was some sort of very destructive weapon that was supposed to go up and chop, I believe, either another robot or something else. Anyway, so one of the RDs was actually going to show this as part of the keynote. And so as regional directors, we're all in the room behind the scenes getting a preview. And the thing goes for about, I don't know,
6 inches.
6 inches, and then just stops. And the room goes quiet, and the RD is up there trying to figure this out, and his little minions are up there too, yelling, "Illumination!" and stuff like that. And so all of a sudden, I get the brilliant idea of Star Wars, and I just scream out, "Uncle Owen, we need another R2 unit. This one has a bad motivator." And the crowd
You did it in that whiny Luke Skywalker voice.
Yeah.
Yeah.
Uncle Owen,
It's R2
I think we need a
unit's
new
got a bad
R2
motivator.
in it. Yeah. And the crowd just lost it. And the person that was doing the demo was not real happy, but I was rolling on the floor.
We were all rolling. We're still rolling.
Everybody was rolling on the
later.
floor. And to this day, whenever I see Carl, what's up, Uncle Owen?
Yeah.
All right. Now that we got that out of the way, we're 15 minutes into the show. We haven't talked at all about ML or anything, except to just mention it in your bio. And I think you just mentioned it. What are you guys doing?
So, last month at Build, we released ML.net, which is a cross-platform, open-source machine learning framework. And really, what it does is it really allows .NET developers to really start to use machine learning directly from C#, F# in your .NET applications to easily integrate custom machine learning into those applications without really much prior expertise in developing or tuning machine learning models. It has a pipeline and just kind of really helps you go through the process.
So if I've used Seth Juarez's .NET client-side library for doing machine learning, I know a little bit about that. Is it similar, or is it at a higher level?
I think it's really actually at a little bit of a higher level. It's a NuGet package that you can download and start using, and basically it's extensible. So support is coming for LightGBM, CNTK, and TensorFlow behind the scenes. So it really is the kind of the front end for your machine learning needs from .NET into other things.
Okay. And do you have to know anything about, algorithms and what to apply? I mean, that's where most people get in the weeds, I think, is they don't know what to do. All they know is that they've got some data and they want to get something out of it, or learn something from it.
Right. The thing with machine learning is really it gives you the learners, it gives you the way to train your model, and really kind of figure out what you want to do. And so the biggest issue that I see is really trying to figure out what what that problem actually is. What question are you trying to solve with that?
Right.
Yeah. That seems to be the point we get to so often now. It's just this, are you asking the right question? Like just going through this process to get to what are we really trying to figure out here?
I have this huge heap of data, and I think I want this. My hypothesis is that I want to figure out what this is actually doing, but then do I have the right data that's going to give me the answer? And
right.
Am I asking the right question? And that's kind of where we're getting to with the sophistication that we've got with a lot of different machine learning networks now. It's getting a lot more away from the actual algorithms and more toward what problems are you trying to solve.
Yeah.
So we should pick a scenario to talk about over the course of the show, because I'm sure it's going to come up again and again and again.
Sure.
I mean, sort of the classic ones, and I think is even on the homepage, is just sort of like credit card fraud detection. Although that's taken care of. Like, you probably shouldn't be building your own for that.
I think maybe we should collect Patrick Swayze's Facebook posts from when he was alive. Because we John probably has access to those.
Yeah. Actually, I did. After he died, I was removed from his Facebook page. But I did for a while. But I think probably a better classification scenario that people would really understand is to start with, 1 and 0. I'm either trying to figure out that something is positive or negative.
Right.
Sure.
Okay, so what if we looked at, either comments from .NET Rocks or comments on Patrick's page and said, okay, we really need to be able to, because we're getting a voluminous number of comments on the .NET Rocks page, we need to figure out and take action if something's positive or negative and be able to do that in a timely manner.
We could expunge all the non-funny comments, right?
Right,
That
like everything that John has said in the whole entire show, that would be great, right? So one of the ways that you can...
I screwed myself. Now I don't have a mid-show joke. I actually have to come up with something.
You just burned your joke.
I just burned my joke.
Oh, well, let's reset the Wayback Machine and go back, and you can try that again, Carl.
I'm sorry, John. Please continue.
That's okay. Oh, that's all right.
Positive or negative comments?
Yeah, positive or negative comments. And so one of the ways that people can get started with their data then is to drop in and to just look at classifying our data in binary classification, positive or negative, okay? We're not looking at multiple values. We're just starting with that. And so once again, understanding that problem becomes a little bit more simplistic, right? Because it's just positive or negative.
Right.
And so we then look at classification to it's either A or B. The whole reason we do that is so that we can take action upon that. And in order to be able to do that, though, this is what we would call supervised learning, in the fact that we have a relative sample of our data that we've already processed and said, okay, this is positive, this particular one, John is great. Carl comes up with great jokes mid show. Those are positive, well, hopefully positive comments. And so we would have maybe that with text, and then in the next column, we'd say 1 for positive for each one of those. And then we might say, John Alexander sucks. His jokes just aren't funny. That might be considered negative. And that might be a 0. And so we run that after creating our pipeline. We pull our data in, and then we use that to build out our model or train our model. And really what we're trying to do is figure out, okay, given something in the data, and we can think of that as maybe like a feature, or what we would call a feature, and that's a property of the data that's being used, like maybe a pet type or sentiment in this case. The actual text itself, and then we use a label to figure out, okay, is this going to actually be positive or negative? And so we use that then to try to train the model, and then we can use that model then on different data then coming in after that. And that will allow us then to take action upon that. So, for example, we could throw that into a workflow or something else to, kick it to our customer service account or billing account or whatever if it comes up with something in there that's negative. Does that make sense?
Yep.
Yeah. So it's what question do I want to answer? Pick the things that I want the machine learning algorithm to analyze, and then pick the trainer, train the data, and when do you get your result? Does it just like spit out when you at a point? And once you've trained it, then you run real comments through it, and it gives you a thumbs up or thumbs down, right?
Right. And the nice thing about the ML.NET framework is this is all really done as a pipeline, so that everything stays together and stays in context. So once you choose your learning algorithm, in this case our binary classifier, we go through and we train that model, we save it out, and then we can also evaluate that. And that evaluates for different metrics based on quality assurance to see, how accurate we are, how close we are statistically, those sorts of things. And then once we've done that, we can go back and train and tweak if we need to. But then we can take another set of data and predict those test data outcomes with that model.
Yeah.
And so one thing actually that I didn't mention is that when we're evaluating that, we want to use a portion of the data that we use to train. So like, for example, maybe you'd use 80% of your data to train, and then maybe another 20% to evaluate, so that you can just go back and make sure that you're getting what you think before you start your predictions. And then you go through and you kind of keep looking at that to make sure that that it's accurate.
John, is binary too tight a measure? Like just the yes or no here? Shouldn't we be dealing with some, certainty range?
Sure, we could. Absolutely. This would allow you, it comes back in terms of a float.
Right.
In terms of what they think the accuracy is for given a given sentiment.
I just want to have the analytics tool give me some sense of I'm not that sure.
Right. And that's where the metrics really come in. To really help you. Is it, how accurate is this? How close? If we look at all those different ratios, things like that, it can give us a pretty good indicator of how valid our model is and how well it's,
how confident it is. We mentioned Seth Juarez already. I just saw him in Oslo, and one of the conversations going on was this training the user to not presume the computer is always right. That this sort of mindset of the tool does analytics, the human has to do the analysis. So we still expect you to look at that and question it. So if we can give it some numbers, so that it's like the machine seems awfully certain here, so that you can look at it differently than the machine is clearly uncertain here.
Absolutely, that's a part of what the evaluation metrics start to give you is kind of the smells of the indicators.
Right.
And then you can take that and use operationalization on your data to really start bringing that into your line of business. But you can't do that until you are at least reasonably sure that's done. So absolutely, you always need to have eyes on what's coming out, and to really make sure then that you're either asking the right question, or you're getting answers that are not just what you want to hear, right? Or, it looks pleasing, so obviously it's okay. When something in the data may have thrown everything off, and so we need to continue to keep looking at that.
So we're doing sentiment analysis, essentially. This is a message flow. How does the system deal with something like sarcasm? Like, this service was so awesome.
Well, I think depending on the examples that you'd already fed it, right? If it had something in there that said this sample was awesome, or this is amazing, it's awesome, it probably wouldn't pick that one up.
Right. Can you do a little like demographic mapping? If it's a 15-year-old girl, that's almost certainly sarcasm. Like, is that
I'm sure that you could. I guess the way it would work is as you move into then a network or a neural network, you can take different pieces and parts and say, okay, this particular sentiment we think is positive. Now let's reflect on who we think is saying that, what other factors you might have there of
right.
what that profile of that person actually looks like to see if it is sarcasm, or maybe we're not totally sure, so we kick that into another queue that immediately goes to a customer service rep so that they can immediately see that. And then, they can, as those are coming through, then somebody can actually tweak that value and then continue to train that. That's and in another product, Lewis, working with language interpretation, you train that model to understand what those labels are, what those those pieces and parts are, and sometimes it gets it right, but you can always go back and change that and then retrain the model based on that so that you're continually getting your efficiencies higher and higher.
And that's Language Understanding Intelligence Service, Lewis?
Yes.
Awesome stuff.
Well, and it's also just this, Microsoft has this huge range of, are they still under the banner of cognitive services? You guys keep changing this name.
They're still under the banner of cognitive services, yes.
Yeah, okay.
So on the spectrum there, cognitive services is really more pre-built pieces for you, and you start feeding in information to it, whereas something like ML.net is a little more custom and allows you to fit the pieces and parts together.
And by that token, John, then, if you really were going to do text-based sentiment analysis, does it make more sense to use ML.net for that, or Lewis?
It depends on what you're really trying to do. If you want to truly incorporate that into your .NET line of business application, then you'd probably use ML.net.
Right, because you get the APIs already there.
Right. You really want to have the control over that. Otherwise, it just depends on what you're trying to do. You could definitely use even, a hybrid of, so part of it's ML.net, and then I send it off to the Lewis API, or vice versa. Maybe, for screening and making sure there's no profanity in there and things like that, you could use Lewis as kind of the first screener, and then send that on in to actually be classified after that.
And thinking back to the comment we had at the top of the show from Maurice, if I wanted an offline solution, I'd be using ML.net. If I wanted to depend on the cloud, then Lewis.
Sure.
All right.
Absolutely.
Hey, Richard.
Yeah, buddy.
Guess what time it is now?
Must be that happy time again.
Yeah, it's time to retrain the .NET Rocks mid-show joke model using data from stupiddadjokes.com. Oh, wait.
I like this.
It's actually the listeners we have to train. I keep forgetting that. Oh,
okay.
Why do I keep forgetting that? Anyway, it's actually time to give away a Telerik Dev. See how I resurrected that joke? You didn't even notice it was the same joke.
You dug it out, man. You got there.
You are the master.
I just had to frame it correctly. I don't know. Maybe I did. Maybe I didn't. It's actually time to give away a Telerik DevCraft Toolkit to one lucky member of the .NET Rocks fan club. But first, let me tell you about Conversational UI from Progress, Telerik, and Kendo UI. Conversational UI are chatbot framework agnostic user interface controls and components that enable .NET and JavaScript developers to create modern conversational chatbot experiences in their web, mobile, and desktop applications. The industry's first packaged set of user interface components built specifically for chatbots are available as part of the company's Telerik ASP.NET Ajax, ASP.NET MVC, ASP.NET Core, WinForms, WPF, Xamarin products, and Kendo UI for jQuery, Angular, Vue, React, PHP, and JSP libraries. In other words, everything. By implementing key UI design features such as calendars, date pickers, list views, and others that are included in the toolsets, developers will be able to improve chatbot conversation through visual elements that enhance the natural flow of conversation. Check out this really innovative library at telerik.com/conversational-UI.
All right, buddy. Who's our winner?
Today's winner is Jennifer DeRicci.
Congratulations, Jennifer.
Jennifer DeRicci.
And Jennifer just won the Telerik DevCraft Toolkit. That's their big pile of awesome, just by being a member of the .NET Rocks fan club. And if you want to join the fan club, go to .NETRocks.com, Click on the big Get Free Stuff button, answer a few questions, and join the club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club. But you got to sign up to win. All right, John, it's your turn. If you had $5,000 to spend on technology today, what would you buy?
I'd like to use Steve Martin as an inspiration for this.
You want
if
the
I
banjo?
had $5,000, I would get all the children together of the world to sing a song of joy and peace. But if I had to use it just on technology, I would actually go out and purchase 50 of the new Xbox adaptive controllers. I don't know if you guys have heard about that.
No.
But actually, it was created by the Xbox team and shown at E3 this past week. And basically, it allows you to hook up any sort of assistive technology and map that any of the buttons on the Xbox controller to that.
Wow!
And so it really makes a difference for gaming. And so the price point for this is going to be $100. And so I would get 50 of those and then pass them out to gamers that need some assistive or that are focused on accessibility and would open that world to them. I'm very much an advocate for accessibility and also starting to use machine learning for that. So being that I have cerebral palsy on my right side, it's just been something that's been very near and dear to my heart. So that's what I would do with it.
Wow, that's great.
I mean, on one side, it's just providing that flexibility to do what you want. But, at the same time, you could also plug in like high-end joysticks and so forth. If you want to, go super expensive, you could go really nuts here. As someone prone to Kerbal Space Program, there's been lots of folks building like space controller-like panels. But the wiring's tricky. This would just make it trivial. Wire whatever you want.
Right.
Right. And this is really, it's pretty ingenious. Along the back side, they have 3.5 inch, I think,
millimeter.
the
3.5 millimeter.
Yeah, 3.5 millimeter, sorry. Brain fart there. Jacks for every button, the D-pad, the directions on the back of that controller, so you can plug those things in. So, for example, on my right side, I have a real problem with the right trigger, and so I use this to use a Rock Band drum switch for the trigger.
So and on then your foot?
Using my foot, and then I remapped the joystick to the D-pad on the other side of the controller.
So you get to favor your left side there, and then use that twitchy foot of yours to fire off as many shots as possible.
Yep, and then you can play Halo at least somewhat with the kids.
Nice.
Yeah, that is cool.
That's very clever, and I love it. It's just a generalized solution for $100. You can set it up however you want.
Right.
Like I'm just looking through the accessories. There's some seriously specialized accessories here, like specifically like breath tubes and things like that.
Right.
But also just buttons.
Right.
Good buttons.
And really big buttons.
Yeah.
So it allows somebody, without really a lot of mobility on their hands to be able to either use breath or feet or elbows on some of those big buttons, whatever that is, and give and opens that up. And turning back around to, machine learning, what if you could use some of the higher end image classification to take a look at how people are moving if they have traumatic brain injury and they use those head movements or eye movements to communicate and then they can't speak. What if we could take those movements then and teach a model to communicate and translate those into actual words?
Yeah. Wow. Yeah. Now you're thinking a whole other level, not just gaming here, but just a flexible input system for anything we'd want to do.
The very first thing I thought of was being able to play Rock Band with an actual guitar.
Yes, maybe so.
Yeah. But even in drum kit or any of these things. But I'm looking at this 3D rudder, which is basically a joystick for your feet.
Mm-hmm. Yeah, absolutely. I'm actually getting one of those. So
interesting. There's a whole other show here now, man. You've stolen it. Like Just experimenting with adaptive controllers. I think we'd have a lot of fun with that.
Okay. Well, I'd love to come back on and maybe get Bryce from the Xbox team or somebody else on.
Yeah.
To talk about that maybe.
Sure.
But it also speaks to ML.net really well, that it's like being able to take the feed of this data from someone and learn their intended behaviors against how they actually controlled it.
Sure. And so, we've got a couple of tutorials in there to get started. And the other nice thing is that this thing is all open source.
ML.net as well as the adaptive controlling stuff?
The adaptive controlling stuff is just a Microsoft or an Xbox controller. I'm talking about ML.net. It's all open source. And on the GitHub repository, there are a bunch of samples that you can use to get started, along with the samples that we have on docs.microsoft.com. But one of the neat things about that is we've talked a lot about binary classification and, positive and negative. But what if you really want to take that now and say, for example, you want to find a value? So maybe like a airline fare price or something like that. And so you want to, you're instead of a positive negative, you're trying to predict a real value, like a double that represents price or something like that, based on some of the other columns or factors in the data set. And so we use a regression task for that to, in the case of the tutorial, trying to predict what the final fare price of a taxi trip would be.
Before you take the trip.
Right.
Wow. So does that fall under the category of predictive analytics?
Yeah, I think so. I mean, it's really more, predictive analytics. Of course. You're predicting something and you're trying to make sure that it comes in within this case, maybe your budget.
Yeah, sure.
Right. If I want to come see you guys from Kansas City and I want to take a taxi, is that going to be is the fare going to be something that I'm going to want to be able to afford when I get there?
Yeah.
Or if we go to pick you up, Carl, on the East Coast, and then drive in a taxi and do a fun road trip out to see Richard, what's that fare look like?
It's going to be a couple of bucks. I'm just guessing.
Yeah, well, I could tell you it's going to be too much.
That's right. That's right. We don't even need Uncle Owen to know that, right?
Yeah, we can work that out.
That sort of brings us to the whole topic of errors in the data and errors in the outcomes and, predictions happening that are sort of socially questionable. I mean, there's a downside. There's a soft underbelly to the whole machine learning thing that I don't know if there's anything technologically in ML.net that helps you avoid some of those situations. It really comes down to the data itself and what you're trying to do with it, doesn't it? But what are some of the pitfalls people will stumble into if they're not careful?
Well, first off is not understanding your data, right? I mean, making sure that your data is cleaned and ready to go is gonna go, I think, a big way toward helping, garbage in, garbage out not happen. Is something that we really want to try to do. Understanding what the problem is, like we've talked about before, but then also on the other side, using those analytics and saving off some of the data if you're pulling in data that you've already given an example for, saving off some of that data so that you can really try to use that to evaluate the model, look at the metrics, make sure they're within the tolerances that you want, and then use that accordingly, and then it's all about ethics, right? It's all about really trying to just use our superpowers for good, right?
Yep.
And make sure that we've got processes in place and that we're really trying to, do the right thing with AI. And as AI becomes more intelligent, we want to make sure that it's helpful and not hurtful, right?
Yeah, sure.
The technology's not biased, it's us.
No, sure,
right.
Of course.
It seems to me the technology just amplifies the bias.
Right. And so we want to make sure that we're looking at that we're actively monitoring for those biases, whatever they might be, because we want to get the true picture of the true answer of what we're trying to answer as opposed to something that's skewed.
Well, here's the thing that will happen, right? So let's say let's just for the sake of simplicity, say you've got 100 records in a data set, and you're noticing after you've trained it with another data set that there's a particular outlier that seems ridiculous, right? Maybe it's you're calculating the trip, a 5-mile trip, and it's like $1,000, right? So obviously there's some bad data in there somewhere. So you go in and you look and you see, oh, I see what this is. There's a typo where somebody entered their fare and, put an extra 0 or extra 2 zeros in there. And that's a problem. So you take that one out. And now, it looks almost okay, but there's still some ridiculous numbers coming out of it. So you go back into the model and you just start pruning it, right? You start fixing errors and fudging numbers, right? And after a while, I guess what I'm saying is, how do you know when to stop?
Well, I don't think you ever want to fudge numbers, right? You want to, if there's something, I think what you want to do in those situations, you want to try to repair the data as best you can. With oversight, with audit, with a clear, those clear trails that you have.
Does that mean just removing the wonky numbers that are obviously wrong? What if you don't know if they're wrong? Well,
that's just it. I was just going to say, how do you know if they're wrong? So what you want to do then is try to use other means, whether it be through AI or just, investigatory work like we've done in the past, to try to figure out, okay, where is that coming from, and what is making that anomaly occur, right? And so once again, it's just grist for the mill to try to really come up with not only tuning our question, but then also understanding what the good answer looks like, right? What the correct answer looks like. It's kind of like the old way that they trained bank tellers how to identify counterfeit money. They train them to really know that $20 bill or that $100 bill so well, the feel, what the different pieces of the engraving look like, maybe even the smell, whatever. They know what the ideal is, so that when something occurs off, they go, oh, wait a second, something's not right here.
Right.
And so the closer we can understand what that ideal is, that's going to be another tool in our arsenal to be able to go, no, this does not look right.
Yeah.
So we really have to, it comes back a lot, I think, to really understanding our data, really understanding what we're trying to measure, what the question is, and then also also having a good idea of what those tolerances are on the other end. So we have kind of a triangulation, if you will, to actually really be able to eliminate biases, clean our data as best we can, and then pre-process it. And
every time we do a show on machine learning or predictive analytics or anything, it always comes down to, data scientists spend most of their time cleaning data, or at least they used to.
Right.
Yeah.
But I also think this you're coming at it with certain biases. The machine, may reflect some of those biases, but sometimes the machine finds stuff you don't want. So you've got this interesting smell test of it might produce results that are accurate that you didn't expect. Like it's interesting to have to scrutinize that. Is it you? Is it it? Is it actually the data? Like there are 3 different variables here.
Right. And so, toolkits or frameworks like ML.net allow you to have a way to use that information offline in your application to be able to then easily pull in the learners that you need to be able to pre-process some of that data, train the model, evaluate the model, and then predict that model and pull that information back out.
Yeah, for sure. Yeah.
What are some of the cool sample apps that you guys have built with ML.net?
Well, there's obviously there's the sentiment analysis that we talked about. We've got a taxi fare predictor. I think I've already talked about that, a little bit about regression. The one that most people start with is just trying to predict what an iris flower, how many petals and things like that are on there. And so that's there as well on the ML.net start page. But then if you go to machine learning -samples, the team has put together quite a few kind of cool samples. One is a GitHub labeler that basically trains your model on your labeled GitHub issues to teach the model what labels should be assigned for a new issue. So that's kind of cool. And it's using multi-class classification to look at several different things, and also the text featureizer to kind of pre-process your data, take out, make sure that it's, maybe lowercase or something like that. But it allows you to play around with that. And so there's the point of, what we're trying to do at Docs and the repos and things like that is just to give the users and the people in the trenches the best information they can to be as immediately productive as they possibly can.
Yeah, that's great.
Awesome stuff.
Yeah.
Do you need GPUs and things? Like we talked about this at the top of the show, but what kind of compute resource are we talking about here if you're going to run it off, especially offline, like on a workstation?
Yeah, really, it's more about the software than the hardware. ML.NET is really, they've tried to really make it as performant and as efficient as possible, and it actually runs pretty darn well, pretty quick on even my Surface machine.
Sure.
So really, it's amazing what the engineers have been able to do with this to create a full-on NuGet package that has a pipeline that you can just pass things through that stays in context and runs pretty darn fast.
Awesome.
Yeah.
So, yeah, and I guess even if you don't support GPUs directly now, you could later. I mean, the upside to being in a framework like this is if it becomes an issue, this is just an implementation issue. Although you guys are able to call into other libraries. Like if you started supporting CNTK or TensorFlow, because both those things definitely use GPU training. Right.
It's been created to be extensible, and so that's coming. Working with CNTK, that's one of the things that the team is working on, on different platforms, things like that. And I know that they're putting out, there's a roadmap out on the repo in terms of what features are coming when. They're releasing new trainers all the time. And so, the thing is, working with the hardware and the GPUs and stuff is really transparent to the user.
Yeah, so you don't need to know. It'll just happen.
Right.
You have the source code. You can use something like Hybridizer.
Right,
from NVIDIA.
Sure. But, they've done it so that really you don't have to.
Yeah.
They've got a lot of optimization going on there, even down at the CPU level. It's pretty darn cool what they've been able to accomplish. And it's actually based on an internal framework that was created with Microsoft Research and is used in some of the ML features in Office and Bing and all sorts of stuff. So it's been around for a while.
Right, yeah. We haven't really talked about this, but you guys have been doing this internally for a long time. You're just surfacing a technology for us to use.
Yep.
Right.
Yep. Dog fooded for your protection.
That's right. And for your efficiency. So,
there you go.
Yeah.
Well, John, it's been great talking to you. And hey, man, we'll see you in Sydney. I know that. But we'll probably see you before then. I
am so looking forward to seeing you guys. If it takes as long as in Sydney, great. Whenever, wherever. I love your show. Just as a little plug for you, Carl. Music to Code By is what I listen to day in and day out.
Awesome.
It's on my, that's what I code by. It is, if you don't have it, you should get it.
Yeah.
It's a great contribution to the developer community by Mr. Franklin.
Why, thank you, sir. It's my secret weapon as well.
Yes. All
right, guys. We'll call that a show. John, we'll see you sometime soon.
Yeah, I look forward to it.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
by the FCC. Yes, I'm a dog.